Hello, thanks for joining. We are going to continue our videos on exploring R and RStudio with an exploration of the console or the command line. So to do that, I'm going to minimize the other windows, make them smaller so that we can just focus on the command line. And the console is this lower left-hand area, as we've discussed. And I'll make the font a little bit larger so that it's easier to follow along. And I hope that you will be following along, that you'll be trying these commands with me as we go through it. We can increase the font size and make it easier to see. Under View, we can just choose Zoom In, or we can use the keys Control plus equals, which will also make it larger. And that's probably large enough for now. So here we are in what's the console, and in the console, we can start to experiment with R. We can introduce ourselves to some of the features and just get comfortable with interacting with basic commands. One of the excellent things about R and RStudio is that there are a number of built-in help functions. So to begin with, let's look at a simple one. If we want help, we don't need to go online. We don't need to check any other source. There are excellent help files all built in right into R. To begin, we can type help, start, open and close brackets. And over here on the right-hand side, in the file viewer in the output, you'll see there's a list, a summary of an introduction to R and how to write R extensions. There's an R manual and so on. Many of those do take you to the R project website. We'll come back to the help files in just a little while, but I wanted to begin by making you aware that hopefully this video is helpful, but even once you're finished this video, you're not on your own. There is a wealth of resources available to help you get to know R. So to begin with, in this command line, and we see the flashing cursor, we can use R just simply as a calculator if we want. So for example, 1 plus 2 plus 4, and it returns the value of 7. You'll notice that there's a square bracket with a 1 and a closing square bracket. Pay no attention to that for now. This is actually an index of what the output is, and later on I'll explain what that means. R also understands order of operations. So, for example, 1 plus 2 times 4 equals 9, which makes sense. 2 times 4 is 8, plus 1 is 9. We can override those just simply by using brackets. So now we have 1 plus 2 in brackets multiplied by 4. So that should end up being 3 times 4, which is 12. Now in R, everything is stored as a vector. And a vector is really just, you can think of it as a 1-by array. It's not precisely that, but it's pretty close to that. Now, the reason for this is that R was originally designed for matrix algebra, and it's excellent for matrix algebra. And with that in mind, it makes sense that everything would be stored as vectors, because a matrix is really just a collection of vectors. So here's an example. I'm just going to type in a few things here. So what I've done here is typed in a sequence of numbers 1, 1, 2, 3, 5, 8. They're separated by commas, and there's this small c before them, and they're in brackets. The c is short for essentially combining, and this lets R know that these are not that these are all sort of separate elements of a vector. And what we see here is it produces that list. If I just typed in a single number, say 13, it would also return that. But if I tried to return 1 and 2, 3, 5, and 8, it'll give an unexpected error, or it'll give an error because it's not expecting that comma there. So if we want to combine it as things as a vector, we need to use the formula above that I've given, or the syntax above is probably a more correct way of saying that. If you've typed something in and you want to reuse it later on, if you press the up arrow key, that will take you back to the previous commands. Now, we'll briefly introduce the idea of variables. There are a number of different data types within R that perhaps in a subsequent video I will speak about in a little more detail. For now, the important thing for you to know is that R has a number of different variable types, and you don't need to specify what type it is when you create a variable. Some programming languages, when you begin a variable, you need to declare the variable, you need to determine or declare what type it is, if it's numeric, if it's an integer, and so on. R won't do that. R will default to what it is the most logical, what it thinks is the most logical outcome or the most logical format for that particular variable. So for example, if I type in this, we'll create a variable a, and I'm going to use the symbol less than and dash, which is pronounced gets. So a gets 10. I've now created a variable a, and I've assigned it the value 10. But you'll notice that nothing printed out. That's because I didn't really ask for anything to be printed out. I just assigned something. But if you look in the environment window, which is in the upper right-hand corner, what you'll see is I now have a variable value a, and its value is 10. So this is a 1-by-1 vector with the value of a. If we want to know what sort of class or data type R has assigned to a, just type in class a, and we see that this variable has been defaulted, or R defaulted to a numeric class for this particular variable. Well, let's assign another vector, and in this case, let's assign a larger vector. We'll call this variable b, and so b gets C for combine, and we'll just type in some familiar numbers, 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. Some of you may recognize what that is. Again, nothing prints out, but if we look over under the environment, we'll see we now have a vector here. It's B, it's numeric, and we see that it has 10 elements. If we type in class, this will also tell us what it is. It's numeric. If we want to print it out, we'll just press B, and it gives us the listing of what all of those elements in that vector are. We have this stored as a numeric vector, and if we can use it as an entire vector, or if we are interested in just one particular element of the vector, we can specify that by B square bracket. And let's look at the 6th element, and we see that that's 8. If we wanted to look at more than just one element of it, we could do B square bracket. Let's say we want to look at the 2nd and the 5th. Now you'll notice here I had to combine. I used the combine function because I've essentially specified within the square brackets a list of every element that I want to look at. And so in this case, it's the second and the fifth element. Another handy feature of R is that if I want to say I want to look at the third to the fifth elements of this, I don't have to type all those in individually. I can just type in 3:5. And what that will return is all of the positive integers between 3 and 5. So in this case, it's going to return the third, the fourth, and the fifth element. And we see that that is, in fact, the case. That's exactly what it did. We can also use R to assess all of the various elements of a vector with a logical value, a true or a false. So for example, if I wanted to find an element that is 13, B equals equals, so a double equal is an evaluation of it, and we'll just type in 13. And what we see is it evaluates the first element to see if it's equal to 13, returns false. Second element returns false, and so on. And you'll notice that it takes all the way up to the seventh element before it returns true, which is 13. We can also use other logical comparisons. So in this case, B not equal to 13. And we see that's the reverse of what it was before. And of course, we can do B less than 13 and B greater than 13, and so on. So you'll see that everything that we are working with in R, it's a vector, and so we always have to keep that in mind, that it's not a single value that we're dealing with. Well, let's assign another vector. Let's call this variable C, and it gets combination 1, 1, 2, 2, 4, 2, 6, 4, 6, 4. Oh, what did I do there? I left a space, didn't I? When I have my C gets. There we go. So again, we can look in the environment and see that a variable's been assigned there. We can print this out if we want. And so we can now start using these together. For example, we can apply arithmetic operators to the entire vector. So 2 times B. And we see that that has given us exactly double all of those values. We could multiply a single vector. So you'll recall the A, we've given it a value of 10. So we could have A times B, giving us a scalar multiple of B. And we see that that is in fact the case. What happens if we multiply B times C? These are two vectors of equal length that both have 10 elements. What might happen? What you'll see here, and perhaps I'll just print out B and C again individually. What you'll see here is it's just multiplied each element by the other one. So the first element by the first element, so 1 times 1 is 1. Second element by the second element, 1 times 1 is 1 again. The third element by the third element, so 2 times 2 is 4, and so on. And then we see 3 times 2 is equal to 6, and so on and so forth. We can deal with two of these vectors. We could have B plus C, which is just adding them together. If we chose A, which again is equal to 10, plus C, what you'll see is it adds 10 to every element in that particular vector. We could also do a subset of vectors. So supposing we wanted the fourth element of B, which you'll recall is 3, and maybe the sixth element of C, which is 2. If we added those together, you see we're able to add those together. So being familiar with vectors, being comfortable with dealing with them, will take you a long way in helping you deal with variables and values and manipulation of data in R, which, as we all know, is a foundational skill needed for all data analytics and all data science. In addition to being able to assign values to variables and so on, there are a few built-in variables, or actually they're constants. For example, pi, 3.1415. In this case, it's rounded it off to 9.3, but it actually has variables, actually has values for that go, or has a precision of the value of pi that goes much beyond just that. There are also a number of functions. Probably a simple one. We'll start with a simple one, maybe the square root function, the square root of 81, which hopefully we know is 9. When you start to type in a function, as I've done there, you'll see there'll be a little pop-up which will start to give you the format of it. Let's say the square root of 64 this time. We can use, say, a sum function. So let's say the sum of B, and that makes sense. You'll recall B is 1 and 1 plus 2 plus 3 plus 5 plus 8 and 13 and 21 and 34 and 55. It all adds up to 143. Let's look at what the square root of A is. You'll recall A was 10. Square root is 3.16. And we can use functions within functions. We can nest them. So for example, we could do, say, the square root of B, which is the square root of all those values, but then we could do the sum of the square root of B, which is going to add all of those up. And there's no limit to the nesting that you can do with functions. Hopefully that's been helpful. Just before we move on, I want to show you a few other handy help functions. So if I wanted more information about the summation function, I can't quite remember how it works. I can just type in help and then the name of the function, in this case sum, and it over here on the right gives me the summary of that. So sum is the function. Base just means that this is part of base R. It's not part of a particular faction or a part of a particular package, pardon me. It gives an overall description of it, gives you some usage, gives you details of it, often will give you examples of how it might work. So a really helpful tool right within the program. You could also just do a question mark sum, and that will return the same information. Suppose you just want an example of the sum function. You're not interested in reading all of the documentation. You just want an example, like how might I use this? Then you just type in example. And what it returns is a whole list of examples of how you might use the summation function. Again, built right into our very, very handy tool to have. The final thing I'll show you for this video is Very often we're trying to find a function. We remember we've used it before, but we can't quite remember what it's called. So in R, is the summation function, is it called sum? Is it called sum with two M's? Is it summary? We can't remember all of the particulars of it. So in that case, we can use the apropos function, bracket, and just type in what we remember. You'll say, yeah, I think I remember it's got something to do with sum. I must have spelt that wrong. I did. I put too many P's. And what this gives you is an entire list of all of the functions that are resident that have sum somewhere in them. So there's summary, there's a summary function, there's summary date, and so on. And this can help you really narrow down what function it is that you're actually looking for. Well, hopefully this has been helpful. This has been an introduction to the console and the command line within R, getting you familiar with some of the very basic commands and how we might work on things arithmetically. Hopefully it's been helpful. Thank you for your kind attention. I hope it's been useful to you. If it has been, be sure to check back next time. In our next video, I'll start introducing you to the idea of how to build scripts in R, and I'll begin to introduce you to the idea of packages in subsequent videos as well, which are also very important things if we want to take advantage of the work that other people have done, or if we want to save our coding for later. But that's for next time. For now, thanks as always. Hope you have a wonderful rest of your day, and hopefully I'll see you at the next video.